Hello students, today we are going to study Wheel of Death or Wall of Death. In fairs or in amusement parks, we had seen that there is a Wheel of Death. That means there is a performer or the stuntman that can perform the stunts by using his two-wheeler or the four-wheeler inside that wheel. But we know that he can do his stunts very efficiently. But if something goes wrong, then that person will be died. And therefore that whale is said to be the wheel of death or wall of death. Okay. Now we are considering a vertical cylindrical wheel inside which a car is moving in horizontal circular motion, or car is performing the horizontal circular motion inside that wheel. Suppose this is the vertical cylindrical wheel, and inside this wheel the performer that is performing the horizontal circular motions on his two-wheeler or on the four-wheeler. Okay, so this is the vertical cylindrical wheel. Okay, so while performing the horizontal circular motion at a particular point, suppose this is the point on that wall, what are the forces acting on this vehicle? In this case we are considering a car as a particle one. So this is the car which is along this vertical circular wall. So what kind of forces are acting on this car while performing the horizontal circular motion? We know that the one force which is acting vertically downward direction, that is mg, that is the weight of the car. The forces acting on this point or on the car, that is mg, that is the weight of car, weight of vehicle or weight of car, that is m into g. It is acting in vertically downward direction. And at the same time, one force which is acting in vertically upward direction, and that is the force of static friction, that is indicated by the Fs. So force of static friction, that is Fs. In this case, the force of static friction, it is along the wall and it is in the vertically upward direction, and mg, it is along the wall and it is in the vertically downward direction. Okay, these two forces can balances each other, and therefore we can write like this, that is force of static friction, that is Fs equals to mg. So while performing the horizontal circular motion inside this wheel of death, force of static friction and weight of the car balances each other. That means this force of static friction that prevents the car from the sliding. Okay. Then another force, that is the normal reaction, you can say that. So this is the normal reaction of the car. It is in the horizontal direction, that is acting in the horizontal direction and towards the center of that wheel. Suppose this is the center, this is the center. So this normal reaction that is acting towards the center, so it is in the horizontal direction. So normal reaction that is indicated by the capital N, it is acting horizontally and towards the center of the wheel. Now the person, it is performing the horizontal circular motion inside this wheel of death. That means when a vehicle is performing horizontal circular motion, then it requires the centripetal force. And in this situation or in this case, the necessary centripetal force, it is provided by this normal reaction. Okay, so we can write like this normal reaction that provides the necessary centripetal force, and we know that for the centripetal force we have the relation that is mv square upon r. So force of static friction that balances the weight, that prevents the vehicle from the sliding, and this normal reaction that provides the necessary centripetal force due to which a vehicle can perform the horizontal circular motion inside the wheel. Okay. Now by using these two relations, we can find out the velocity, minimum velocity required for that vehicle to perform the horizontal circular motion. If the velocity goes on decreasing beyond a certain limiting value, then that may be the wheel of death for that stuntman. So to perform the horizontal circular motion, a performer must be moving with a particular limiting velocity. Okay, so we can determine that minimum velocity required for this horizontal circular motion. So by using these two relations, we can determine the minimum, that is the limiting velocity. We know that static friction, it is always directly proportional to the normal reaction, and therefore we can write like this: the force of static friction that is equals to mu s into n, where this mu s, it is the coefficient of static friction. This is the coefficient of static friction. Okay, and from this relation we can determine that is Fs upon n equals to mu s. Okay, on dividing equation number 1 by 2, we get that is Fs upon n equals to, that is mg upon mv square upon r. So this get cancelled, and Fs upon n, this is the ratio of coefficient of static friction. So we can write like this: therefore mu s equals to, that is rg upon v square, and therefore v square equals to, we can write like this, rg upon mu s, and finally that is v equals to under root, that is rg upon mu s. So this is the limiting velocity, or we can say that it is the minimum velocity. So we can write like this also: this is the minimum velocity with which a vehicle can be safely driven along this, that is the wheel of death. Okay, so performer must be driving his vehicle with this velocity. Okay, so this is the wheel of death. Thank you.